example 1.12, we have to find using horizontal line test, we have to determine the following functions are one-to-one or not. So we will see what an horizontal line test is. We already saw vertical line test. Now we are going to see horizontal line test. So horizontal line test is defined as a function represented in a graph is one-to-one if every horizontal line intersects the curve in at most one point. So horizontal line tests also represent the same. We use vertical line test to find whether the given curve is a function or not, whereas in an horizontal line test the given curve is a function. Why it is used horizontal line test is to check whether the given function is one-to-one or not. So we have to know the difference between the both vertical line test and horizontal line test. Vertical line test is used to check whether the given curve is a function or not. Horizontal line test is used to find whether the given function is one-to-one or not. Let us see now. So in the first example, this is the horizontal line given and this is the curve given. Given curve is a function. We should use horizontal line to check whether this given function is a one-to-one or not. So according to this also the same thing, which means if the horizontal line touches the curve at most one point, then it is called as a one-to-one function. The horizontal line touches the curve at only one point P. Therefore, this is a one-to-one function. And the second option, if you see, the horizontal line touches the curve at 2 points P and Q. Therefore, this is not a one-to-one function. And in a third example, similarly, this is the horizontal line given, this is the curve given, this is a function. We have to check whether this is a one-to-one or not. The horizontal line intersects the curve at only one point. Therefore, this is a one-to-one function. So in example 1.13, we are given with two set of values A and B. Also we are given with a function which we have to plot from A to B. What we have to show that is f is one-to-one but not an onto function. Let us do so. We will use an arrow diagram to represent this. A is given as 1, 2, 3 and B is given as 4, 5, 6, 7. See, according to the given function, 1 is mapped to 4, 2 is mapped to 5 and 3 is mapped to 6. Whether it is a one-to-one function? Yes, it is a one-to-one function because every element in A, that is distinct elements in A, have distinct images in B. Therefore, this is one-to-one function. We will check whether this is an onto function or not. It is not an onto function. How do I say it is not an onto function is the element 7 in B which is not an image of any element in A. There is one element which is not an image. So which means this is not an onto function. So we have shown both one-to-one but not onto as well. Hence proved. Okay, in example 1.14 it is given as the set A and f is a mapping from A to B. It is an onto function, which means f is a mapping from A to B. They said it is an onto function, which means the range of f is equal to the codomain of f. Defined by the function f is given as x square plus x plus 1. With the help of this function and the values of A given, we have to find the values of B. It is very easy to do so. Let us find, which means in general, if f is a mapping from x to y, we can write it as f of x is equals to y. Now what will we do is, we will consider the function f of x given, which is given as x square plus x plus 1. We will consider this as an equation 1. We will substitute the values of x as the values given in a 1 by 1, which will give a solution which is nothing but the value of a y. Let us do it one by one. First we have to consider the value of x is equals to minus 2, which is given in a. So f of minus 2 we have to substitute in place of x. Minus 2 squared plus this value is minus 2 plus 1. Minus 2 into minus 2 will give me plus 4. Minus into plus will become minus 2 plus 1. 4 minus 2 is 2. 2 plus 1 is 3. So for value of a equals to minus 2, we got the value of b as 3. Next I will use the value of x as minus 1, which means minus 1 squared plus minus 1 plus 1. Minus 1 into minus 1 will become plus 1. Minus into plus minus 1 plus 1. So we will cancel 1 plus 1 and 1 minus 1 will get cancelled, which is equals to 1. So when x is equals to minus 1, we got the value of y as 1, which is nothing but the value of b. Next we will find for 0. So if it is f of 0, we have to substitute the value of x in 0. So 0 square plus 0 plus 1, 0, 0 plus 1 will only give me 1. So when I took the value of x as 0, we got the value of y as 1, which is a repetition. Next we will substitute the value of x is equals to 1 as given. So when I substitute 1, it will become 1 square plus 1 plus 1. 1 square is 1 plus 1 plus 1, which is nothing but 3. So when x is equals to 1, I got the value of y as again as 3. Next the last value we are going to do is f of 2. F of 2 in the sense we have to substitute the value of x as 2 in equation 1. 2 square plus 2 plus 1. 2 square is 4 plus 2 plus 1. 4 plus 2 6. 6 plus 1 7. So when x is equals to 2, we got the y as 7. The values of b are nothing but the values we yielded. 1 is a repetition, 3 is a repetition and 7. So b is equals to 1, 3, 7. So we found the value of b as asked the question. So in example 1.15 it is given as, let f be a function and f is a mapping from a natural number to another natural number. What does it mean? Natural number starts with 1. Be defined by f of x, the function f of x is given as 3x plus 2. For every x is an natural number. We are asked to find these three things. The first one is we have to find the images of 1 to 3, and the second one is we have to find the pre-images of 29 and 53, and third one is we have to identify which type of a function is given. We will do one by one. So let us consider the function given f of x is equals to 3x plus 2. I will consider this as an equation 1. In the first option, we are asked to find the images of 1, 2, 3. Images of 1, 2, 3 means we are given with the value of x. We have to find the values of y. So, first what it is given, when x is equals to 1, we have to substitute in f of x, which means f of 1 is equals to 3 into 1 plus 2, 3 plus 2, 5. That is, the image of 1 is 5. Next, we are given with to find the value of x is equals to 2. That is, the images means we have to consider the given value as x values. So f of 2 is equals to 3 into 2. We are substituting here plus 2. 3 2s are 6. 6 plus 2, which is 8. Next, value of x we are asked to find is 3. So f of 3 is equals to, we will substitute 3 in x. Therefore 3 into 3 plus 2. 3 3s are 9 plus 2, which is 11. Therefore, the images of 1, 2, 3 are 5, 8 and 11. So thus we have found out the images. Next, second option, we are asked to find the pre-images of 29 and 53. What does it mean? Pre-images means we are given with the value of y and we are asked to find the values of x. So in general we know that if f is a mapping from x to y, f of x can be, f of x is equals to y, which means we are given with the value y. I'm taking the equation f of x is equals to y. First we are given with the value of y as 29. Therefore I'm writing f of x is equals to 29. I was also given with the function f of x. I'll substitute in place of f of x as 3x plus 2, which is equals to 29. We'll simplify this. 3x is equals to 29 plus 2. If it goes to the other side, it will become minus 2. 3x is equals to 29 minus 2, it is 27. X is equals to 27 by 3. 27, if it is divided by 3, will give us a value 9. So the pre-image of 29 is 9. Next, we are asked to find the pre-image of 53. Let us consider the same. F of x is equals to y, which means the y value it is given as 53. F of x value is also given, which is 3x plus 2 equals to 53. 3x equals to 53 plus 2. If it goes to the other side, it will become minus 2. 3x is equals to 51. Let us write this as 51. 3 if it goes to the other side will come to the denominator. 51 when it is divided by 3 will give us a quotient 1 times 3, 2, 1, 7 times. So x is equals to 17. The pre-images of 29, 53 are what we got, 9 and 17. And the third subdivision, what we have to do is we have to identify the type of a function. Let us do so. So to identify the type of a function, we should write the two sets, whereas we are given with it is that is f is a function from a natural number to another natural number, which means the set A is also natural number, set B is also natural number. Natural number means it starts with 1, 2, 3, 4, 5, 6, it goes on. Similarly, B should also be filled as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, it goes on. See, we already found the values of x, which means when I put x is equals to 1, I got the value as 5. So 1 is mapped to 5. Next, for 2 also we found, if I put the value of x is equals to 2, we got the value of y as 8. So 2 is mapped to 8. Similarly, we have got the value for 3 also. When x is equals to 3, we got the value of y as 11. Therefore, 3 is mapped to 11. From this itself, we can conclude which type of function it belongs to. If you take an element in A, that is every distinct elements have distinct images. Similarly, if I take the value of x as 4 and substitute here, I will get another image, which means every distinct elements have a distinct images. One thing. So, therefore, this is a one-to-one function. As well as what we can find is many elements which is not a pre-image, which doesn't have a pre-image. Therefore, this is a into function. It is one-to-one and an into function. So, the next example 1.16 is forensic scientists can determine the height of a person based on the length of the thigh bone. They do so by using the function h of b is equals to 2.47b plus 54.10, where b is the length of the thigh bone, which means forensic scientists can find the height of a person by knowing the length of the thigh bone, and it is given by the function h of b is equals to 2.47b plus 54.10, and we are asked to find three subdivisions. First one is we have to find whether h is 1 to 1 or not, and the second one is we have to find the height of a person. Length of a thigh bone is 50 centimeter, which means b value is given. We have to find the value of h in the second subdivision, and in the third subdivision we have to find the length of the thigh bone, which means we have to find the value of b. Height of a person, that is h value is given as 147.96. Let us do it one by one. So first thing is what we have to do is we have to verify whether the given function is 1 to 1 or not. So if a question is given to, if a question like this is given to us, we can use the 1 to 1 function as, which means for every a1 and a2 in A, f of a1 equals to f of a2, which can imply a1 equals to a2, then we call it as a f as a one-to-one function. We can use this definition also to find whether the given function is one-to-one or not, which means we can take f of a1 is equals to f of a2. From this, if we can bring the value as a1 equals to a2, then we call as f of s one-to-one function. We are going to use this method to find whether h is a one-to-one function or not. How to use that? So what am I going to do is, h of b is given as 2.47b plus 54.10. We will consider this as equation 1, and as I told you, we will use this definition to find whether h is one-to-one or not, which means we will take h of b1 equals to h of b2. From this, if we can bring b1 equals to b2, then h is called one-to-one. If not, then we say h is not one-to-one. From this, h of b1 equals to h of b2, if we can bring b1 equals to b2, then we call h is one-to-one. If we cannot bring b1 equals to b2, then h is called as not an one-to-one function. Let us do so. So h of b1, in the sense, in place of b, we can substitute b1 here, which will become 2.47 b1 plus 54.10. Similarly, h of b2, in the sense, we have to substitute the value of b as b2. So it will become 2.47 b2 plus 54.10. So 54.10 will directly get cancelled, because if I take 1 to the other side, it will become minus. Therefore, we can directly cancel it. The remaining will be 2.47 b1, which is equals to 2.47 b2. Here also 2.47 and 2.47 will get cancelled. We got b1 equals to b2. As I already told you, according to the definition, if we can bring f of a1 equals to f of a2 as a1 equals to a2, then f is called as a one-to-one function. Similarly, we took h of b1 equals to h of b2, and from that we got b1 equals to b2. Therefore, h is a one-to-one function. We have completed with the first subdivision. We will do the second one. In the second subdivision, we have to find the height of a person, whereas we are given with the length of his thigh bone. Length of his thigh bone is represented as b in this problem. Therefore, b value is given as 50 centimeter. Now, what we have to do is, in this function, we have to substitute the value of b, and we can find the value of h simply. So, h of b equals to 2.47 b plus 54.10. b value is given as 50 to find the value of h. Therefore, h of 50 is equals to 2.47 into 50 plus 54.10. So, 2.47 into 50 will give us 2.47 into 50. 5 7s are 35, 3, 5 4s are 20, 23, 2, 10, 12, 0. So, there is a point, there is a decimal point after two numbers. So, we have to place the decimal point before the two numbers. So, the value is 123.5 plus 54.10. 123.5 plus 54.10, 06771. So, h value is 177.6 centimeters. Thus, we have found out the second option. Third option we will move on to. And in the third option, we are asked to find the length of the thigh bone, which means we are asked to find the value of b. For that, we are given with the value of h is equals to 147.96 centimeter. For that also, we will consider the same function. H of b is equals to 2.47 b plus 54.10. We are given with the value of h, which is nothing but 147.96, which is equals to 2.47 b plus 54.10. We will take this 54.10 to the other side. It will become 147.96 minus 54.10, because if this side it is plus, if it comes to the other side, it will become minus, which is equals to 2.47 b. So, we will simplify this. 147.96, which is can be subtracted 54.10. 6, 8, 3, 9. So 2.47b equals to 93.86 and b equals to 93.86. This will bring to the denominator 2.47. In both numerator and denominator there are 2 points after the decimal, so we can multiply and divide by 100. b equals to 93.86 into 100 divided by 2.47 into 100. The next step, it will become 9386 divided by 247. Let us simplify this. 9386 is divided by 247. Let us choose 247 into 3. 21, 2, 12, 14, 1, 6, 7. So 3 times 741. So 7, 9, 1. Remaining 6. I'll choose 247 into 8. Therefore, 8 sevens are 56, 5, 32. 32 plus 5, 37, 3, 16, 19. So 8 times 1976. So B value equals to 38 centimeters. Next we are going to see is special cases of functions. So we have 3 categories under this. First one is constant function. Second one is identity function. And the third one is real valued functions. We'll see one by one. First is a constant function. A function f is a mapping from A to B is called as constant function if the range of f contains only one element. That is, f of x is equals to c for every x in A for some fixed c in B. What does it mean is, let me explain with an example. I will consider the set A and B. Set A as 1, 2, 3, 4 and B as A, B, C. So I will consider example to explain a constant function. 1 is mapped to B, 2 is mapped to B, 3 is mapped to B and 4 is also mapped to B. If you see in this function, all the elements in A have the same image in B, which means this is a constant function. That is, the range of f contains only one element. If all the elements in A is mapped to the only one element in B, then we call it as a constant function. Next we will see an identity function. Next is identity function. A be a non-empty set f is a mapping from A to A is called an identity function and it is denoted by IA, whereas the identity function is always represented as IA. What does it mean if it is a mapping from A to A, whereas the image and the pre-image, if it is same, then it is called as an identity function. I will explain this with an example. We will consider two sets A and B. X has a set of values, A has a set of values x, y, z and B has also the set of values x, y, z. If x is mapped to x, y is mapped to y, z is mapped to z, then this is called as an identity function. Whereas the image and the pre-image are the same. Whereas I can write this in a set of ordered pairs as x comma x, y comma y, z comma z. When the elements, both the elements are same, then we call it as an identity function. And the third one is real valued functions. A function f is a mapping from A to B is called real valued functions. If the range is the subset of the set of all real numbers. If the subset is if the range is the subset of all the set of all real numbers, then we call it as a real valued function. That is f of a, that is range is a subset of R. Then it is called as a real valued function. So in example 1.17 it is given as, let f be a function from a real number to another real number, and it is defined by the function f of x is equals to 3x minus 5. Now we have to find the values of a and b, and for that we are given with the set of ordered pairs a comma 4 and 1 comma b. They both belongs to f. Let us find the values of a and b. So what it is given is, we are given with the function f of x is equals to 3x minus 5. We all know when f of x is equals to a value is mentioned, this is nothing but f of x is equals to y in general, which means this is the value of y. So this can be written in a set of ordered pairs. F can be written as x comma 3x minus 5. So here it is x, therefore x, 3x minus 5 represents the y, 3x minus 5. Next, what we are given with this two set of ordered pairs, I will consider a comma 4 first. A comma 4, what does it mean? The image of a is 4, which means a is mapped to 4, the image of a is 4. A comma 4 means the image of a is 4. Then how should we write? We should write it as f of a equals to 4. A is mapped to 4. This is in x position and this is in y position. So if f is a mapping from x to y, we can write it as f of x is equals to y. I use the same procedure to write this. It means a is mapped to 4. Therefore f of a equals to 4. Now what we are given with this? We are given with the value of f of x. So in place of x, we can substitute x as a, since it is given in such a way. So in this, I am going to substitute the value of x as a. So what will it become? 3a minus 5, which is equals to 4. We will simplify this. We can get the value of a. 3a equals to 4 plus 5. If it goes to the other side, it will become plus 5. 3a equals to 9 and a equals to 3. So thus we have found out the value of a. Similarly, using the other set, we can find the value of b. 1 comma b. What does it mean? 1 is mapped to b, which means the image of 1 is b. How should we write? F of 1 is equals to b, which means instead of f of 1, that is f of x, in place of x we can substitute the value as 1. It is given, so it will become 3 into 1 minus 5, which is equals to b. 3 into 1 is 3 minus 5 equals to b. Minus 5 plus 3 will give me minus 2. Therefore b equals to minus 2. Thus we have found out the values of a and b as we are asked to find. Next is example 1.18. In this function, f is a mapping from R to R is defined by f of x is equals to, it is categorized as 3 types, and we have to find the values of these 4 subdivisions. What am I going to do is, f of x is given in 3 categorization. First I will plot it in a graph, then we will move on to the problem. Only x-axis I am considering because only it is given as the values of x. 0, 1, 2, 3, 4, 5, 6. Minus 1, minus 2, minus 3, minus 4, minus 5. So first is f of x is defined as, that is given as 2x plus 7 if x value is less than minus 2. Here only it is given as less than, therefore minus 2 is not included. That is why I am using open brackets. If f of x is less than minus 2, f of x value is 2x plus 7. Next, the second one is if x varies between minus 2 and 3, whereas here minus 2 is included, therefore I am using closed brackets. The closed brackets represent that minus 2 is also included, whereas 3 is not included. So we are using open brackets. When it is x varies between these, then f of x value is x square minus 2. And the third one is x value is greater than or equal to 3. Greater than or equal to 3 in the sense the 3 values also included. Therefore, I am using the closed brackets. When it is greater than or equal to 3, f of x is given as 3x minus 2. Let us divide this interval as first interval, second interval and the third interval. We will represent as such. Now we will find the given 4 subdivisions. In the first subdivision, we are asked to find f of 4. F of 4 in the sense the value of x is equals to 4. The value of x is equals to 4 falls in the third subdivision. So we have to use the f of x value as f of x is equals to 3x minus 2. So in place of x we have to substitute 4. F of 4 is equals to 3 into 4 minus 2. 3 4s are 12 minus 2, 10. Therefore, f of 4 is equals to 10. In the second subdivision, we have to find f of minus 2. F of minus 2 in the sense, minus 2 in the interval falls over here, which means we have to use the second interval. Whereas in the second interval, f of x value is x squared minus 2. Therefore, in place of x, we have to substitute minus 2. Minus 2 squared minus 2. Minus 2 into minus 2 will give me plus 4 minus 2. 4 minus 2 is 2. F of minus 2 value is 2. And in the third subdivision, we have to find f of 4 plus 2 into f of 1. F of 4 we already found in the first subdivision. We know the value as 10. We will find the f of 1, then we will substitute in this. F of 1, x value is 1, which means it falls within the range that is in the second interval. Therefore, we should use the f of x value as x squared minus 2. Therefore, f of 1 is equals to 1 squared minus 2. 1 squared is 1 minus 2. Minus 2 plus 1 will give me minus 1. F of 1 is equals to minus 1. F of 4 we already found it as 10. Let us substitute in this. F of 4 is 10 plus 2 into f of 1 value is minus 1. Therefore, 10 plus into minus minus 2. 10 minus 2, 8. So, f of 4 plus 2 into f of 1 is 8. So next is fourth subdivision. Fourth subdivision, it is given as f of 1 minus 3 into f of 4 divided by f of minus 3. So in this we already found the value of f of 1, which is nothing but minus 1. F of 4 also we found in the first subdivision itself. We got f of 4 as 10. Let us find f of minus 3 and we will simplify. So f of minus 3 means x value equals to minus 3, which falls in the first interval. Therefore, we should use the value of f of x as 2x plus 7. So, f of minus 3 equals to 2 into minus 3 plus 7. 2 into minus 3 is minus 6 plus 7. Plus 7 minus 6 will give me 1. So, f of minus 3 is equals to 1. Now, I am going to substitute in this. We know the value of f of 1, which is minus 1. We know the value of f of 4, which is 10. And we know the value of f of minus 3, which is 1. Let us substitute in this. So, f of 1 is minus 1. Minus 3 into f of 4 value is 10 divided by f of minus 3 value is 1. So, minus 1 minus into plus, minus 3 into 10, 30 divided by 1. Minus 1 minus 30 is minus 31. So this is the value for the fourth option.